Okay, so right now we will tweet about our last completed shuttle search. Oh, we actually also need to submit to GitHub. Last time it was quick finish, so I wasn't able to send anything about the victory achieved. So equations. Equation with ZS. Equation. Does it make sense? Equals equation. Okay, equation. Okay. Yes, equations with S. Okay. Okay, seems like YouTube hasn't started. Interestingly, why? No, it started. Okay. Cool. Next day, 14. As your ferry approaches the seaport, the captain asks for your help again. The computer system that runs this port is incompatible with the docking program on the ferry, so the docking parameters aren't being correctly initialized in the docking program's memory. After a brief inspection, you discover that the seaport's computer system uses a strange bit mask system in its initialization program. Although you don't have the correct decoder chip handy, you can emulate it in the software. The initialization program, your puzzle input can either update the bit masks or write a value to memory. Values and memory addresses are both 36-bit unsigned integers, for example, ignoring bit mask for a moment, a line like memory 8 equals 11 would write the value 11 to memory address 8. The bit mask is always given a string of 36 bits, written with the most significant bit representing 2 in the power of 35 on the left and the least significant bit 2 to the power of 0, that is the first bit, on the right. The current bit mask is applied to values immediately before they are written to memory. A 0 or 1 overrides the corresponding bit in the value, while an X leaves the bit in the value unchanged. For example, consider the following program. Mask equals something, memory 8 equals 11, memory 7 equals 101, memory 8 equals 0. This program starts by specifying a bit mask. The mask it specifies will override 2 bits in every written value. The second bit is overwritten with 0 and the 64th bit is overwritten with 1. 64 means 2 to the power of 6, so it means the 6th number. No, 7th number. The program then attempts to write the value 11 to address by expanding everything out to individual bits. The mask is applied as follows. 64 is written to the initialize, or to initialize your Fairies docking program you need the sum of all values left in memory after the initializing program completes. The entire 36-bit address space begins initialized to the value 0 at every address. In the above example, only 2 in-memory values are not 0, 101 at address 7 and 64 at address, that's actually 101 at address 7 and 64 at address 8, producing a sum. Execute the initialization program. What is the sum of all values left in the memory after it completes? Cool. So let's copy our example program. Advent of Code is just a fun event that happens in December, and each day you have one problem to solve, and I'm behind the schedule, so if we look in the calendar of Advent of Code, I solved 13 problems and we right now have 20 of them. So I'll need to solve 7 to get into the schedule. The last will be just before the Christmas at 25th of December. here the input is quite complex, so we will use parser combinators to parse it. So let's import what's called import text read no, something text parser combinators, I believe, something. No, I forgot. Let's Google it. Text parser combinators. Okay. Oh wait, did you say text parser combinators read precedent. Import text parser combinators text precedent. Wait, haven't I imported? So read precedent, or is it just read? Oh yeah, I need to import it to lift. And the read precedent, I believe, is in import text read. Text read. I don't remember. So read, and read has a read precedent, which is just read. Okay. Import read, text read. Yes, text read. And here we have read precedent. Text read precedent. Okay. So also what we want to have is read text, not text bracket, read bracket, read p, and read p. So we will have mask, which is read p, which will read a mask, and mask is just int value. So what mask is doing is reading a line, yes, string. So it will read string mask equals to something with spaces, and then it will read a string until the end of the line. But also what we can do is mask str manage and lm of 0, 1 or x, and manage will right, I can do qualified, so I will just refer to all the functions here as p.something and don't need to import each function separately. Read p, yes, p string. So it will munch, or it will take all characters which are element of the string, so 0, 1 or x, and then it will stop parsing. And then we need to convert. Alright, so our mask shouldn't be just an int, because we need somehow to differentiate between 0 and x, because if it's x we don't change the value, but if it's 0 we should change the value. Okay, so the way to do it, as I see, is so we will have two masks. One mask is for numbers that we are writing, and the another mask is for a number. Oh no, we need one mask, so what we'll do is we replace one mask for number we are writing. So we will keep bits from the number 11 or 101 only, which are masked here as x. And to result we will add the number, this one number, but we will replace all x with 0, and this number we will add to result of masking the input number, and that will work. So to do this we just need to create a mask as a number, and we need to replace all x with 0 and all not x with 1. Actually all x's with 1 and all not x's with 0, because x's is the bits we are taking from the input number, and zeros are which we disregard from input number. So what we will do here is map of mask str, and it will be simple replace. Yes, we will compare it to x. Each character we compare into x, and it will output 1 for x's and zeros for anything else. And what we can do is from enum. From enum is a function that takes some enum, and bool is enumerable, because we can say that false is 0 and true is 1, and it will convert to int. So result here would be a list of numbers of 0 or 1, and we just need to convert it to the number. I believe there is data bits, but I don't remember whether there is a function to convert a list of bits to the number. Complement 0 bits, bit, set bit clear, test bit size, shift L, rotate pop count, finite bit size, count leading 0, count bit default. Okay, let's check what classes are considered to be bits. Integer, wow, nice. Can we have a function that takes a list of bits? Doesn't seem that there is a function here. So what we'll do is Google for function, because it should be there. Haskell convert the list of bits to the integer. Of course I know how to do this, to write a function, but I don't want to re-implement the wheel, and just want to use a standard function, convert to bits. Convert from bits. Okay, here, oh, to bits 8. No, not to bits, from list. Also fold. I would expect to have a standard function. Okay, this packages bit array. Split number into its digits, converting. Oh wait. What we can do is to use a function read, because we definitely have function read which takes function read int, I believe. Import data read. No? Probably text read. And here we should have read int. Read either, read list, read maybe, read precedent, reads. Wait, I definitely remember the function read int. Oh, parse int maybe. Numeric, I see. Import numeric. Read int. Okay. And read int allows us to specify let's see the documentation. It allows us to specify the bits, and function converted a valid digit character to int. So we can read binary. Do we have read binary? No. Okay. So yeah, we actually can read int instead of converting to ints and then to read. Yeah, so instead of doing this, we will do read int. And we will have a base of 2, distinguishing valid digits in the base. Yeah, so it should be lm of 0, 1 and x, and we will need to convert basically that's the function that was before. If that's x, it's a 1. If it's not, it will be 0. Yeah. So I was complaining before that read int is too abstract. The function you pass, you can do read binary functions that will be less abstract and more specific. But here, read int is actually helping us, because we not only want to parse 0 and 1, but also x. And here we can specify how we want to parse. So that would be our result. Okay, we parsed the mask. Now we need to parse an statement, which memory, which value we want, and let's have maybe a statement class. Yes, let's say we have statement. And in statement we have address, and we have value. Not value probably, but okay, value. That's fine. Deriving show to print the statement if we want, and we want to statement to be a part of read, and we will define read precedent with lift because we don't care about precedent, but still we want to read, and the first function to read is just to parse memory square. Yes, then we will have we will need to parse int. So the way to do it is to munch is digit, and this digit is function from data character, and this string we will just say read, and it will read an int. Then we'll need to parse closing bracket, space equals space. We also, instead of space, we could write function spaces or just space, and it will parse any number of white spaces, and it will parse also tabs, new lines, and so on. But we don't want to make solution complex, so we just leave it as this here. In case the syntax will be changed in star task, we will change it easily. So here we have the same, only we need to parse a value. So it will be a read p munch is digit. And result is a statement with address and value. Let's try to compile. In the data unexpected type, a int value int. Right. So here we should have a constructor, which will be the same as the name of the time. Not in scope munch. Perhaps you mean pmunch. Yes, that's exactly what I mean. Pmunch. And also read precedent is not a visible method of class statement. Right, so we have read. Yeah, we should put read before. Let's start with the last one. Couldn't match type read pass string with character, with a list of characters. Yes, but I have do here, right? So, oh right. So what I need to do here is this operator, because munch returns not a string but parser string. So I need, and parser is a monad, so I need to modify the value inside monad. So that's why I will use this operator. 19. Oh, what does read int return? Read s. And what read s is? Read s. Okay, I see. Okay, so Yeah, I understand why here. How can we do this? So we say it's read S. Can we read S or something like that? Yeah, so we in the monad read P. So what we can do, we can convert this monad. Alright, we can do read S to precedent, and that would be it. We also need to have some precedent to convert. Okay, I don't know what precedent we should. Let's say 0. Oh no, so I see. So we need to pass a function that takes precedent and parses. But we don't care about precedent, so we can just parse. So it will look like read S to precedent, and here it will look like const and this function. Yes, and it will be read P, so we don't need to return. We don't need to wrap. The only thing now is, yeah, we need to have P. Read S to P, yeah. Nice. So in the main function, what we will do is read file from the first argument, and we will have lines. And each line we can parse. Yeah, so we will have maskester here as the first line, and we will have statements. Statement. Yeah. Statements. Rather Statementer. Perfect naming. So how we will do this is so we have read P int. How do we apply this parser to what we will do is to convert P to S, and we will case onto the wait, what is the value of, yeah, I believe that's readback as a function, right? No, it's something completely different. What is readp? Readp? You don't know what's readp, but it's right here. P readp. Readp. What's that? P readp. is a function that takes A and returns the parser combinator. It will receive such function and will return you another parser combinator. I don't understand what that is, so we will for parsing mask_str we will use read p to s, and I know what's read s, because for read s you can just pass mask_str.
Driving along, saw a cliff, that's a pretty big fall, I could break a rib. And if I drove off, I could start again, but I won't. Side of the road, stretch my neck, it's so cold outside.
Okay, so what I can do,
if I slept here, I would catch my death,
I will introduce just a super simple type mask, which will be a wrapper around int, and I will say instance read mask where read precedent equals read precedent equals the function that we defined before. What that gives us, because read int returns read sa, and we've given number a, so it will return int. Since it's returning int, so we will need here to say
cause I get too bored, can't control my mind, and then I'm scared.
Okay, so after read int here,
running on feelings that are both in the past when you were so close.
We'll need also to have a constructor mask, so it will be our mask and not just any int. And after we set that, we can easily to use read to read a mask. And also we can use read statements as well. Only one thing is we need to have map read, because we have a list of statements. Okay, sounds good.
I stay home on weekends to process the past. Supposed to be angry, but that's not the vibe. I miss you like crazy, but I know we went right. I try to stay hopeful, but lonely at night. I'm just stuck on you. I'm just stuck on you. There ain't nothing I can do. I'm just stuck on you. There ain't nothing I can do.
Yeah, so next what we'll do is to actually process statements, and we will have memory, which is just a map of values. Let's say we have init memory, which would be, technically it's an array, but I predict that we will not use most of our memory, so I don't think there is a value into allocate all this memory, so we just use data map. It's empty in the beginning. What else we have? So we also need a function to exec statement, which will take statement, will take memory, and will return memory, new memory. So So statement will have other and value, and memory is just a map. Oh, we also need a mask, right? So mask will be just one value, so it should be the first argument because it won't change often. Mask. Okay, so what we will do, result will be insert or update. So why update is because what if the address in memory doesn't exist? Oh, it doesn't matter because we don't use the value which is stored inside this space. We'll insert no matter whether value already exists or not. We will rewrite the value. So insert by the address, and the only question is only what value. So we will apply value to mask, and thanks to the data bits we have a function for bit masking, which is end. So we can mask value, but that's not only thing that we need to do. We also need to add yes, we need okay, so here mask is not only which bits we will take. Okay, so yeah, that's how I thought. So right now masks is 1 in the place of X and zeros to all other places. Okay, so we cannot just invert. So good thing that we created a type for mask, because after thinking more, mask should have two values. First one is to is mask for input, and second one is for it's like additional value that we need to add is sort of replaced. Let's call it this way. It would be input mask, and this would be replaced symbols. Let's say like this. So we need to modify read mask, because yeah, we will need to read differently. So this will be input mask on input, sort of mask on input, and this will be replaced bits. Yeah, best names I can come up with. Mask on input, and we have similar function for replaced bits. It would be the same satisfying function, and here we will say that all x should be read as 0 and all others should be read as they are. So we will say, okay, it won't be that simple, so we will probably need to do here a conversion function. No, we can say like that. If it equals 1, then it will be 1, but all others are 0. Nice. Really simple. Mask on input and replaced bits. Yeah, that's good. Mask on input. So we'll have a mask on input and replaced bits. So here we have mask on input plus replaced bits, and that should be it. Yeah, I believe that's it. So what we will have is fold L. The function is exec statement, and we have mask. And fold L. So okay, fold L takes the accumulator value from the left, so we will need to flip. I mean, since this one function used only once, we can just do like that. M statement memory. Yes. So we will have this function which can be passed into fold L. Init memory. Memory, and we have list of statements. Yes, and we will just print the result. Wait, result is a memory, so what we will need to print is a sum. I believe map doesn't have sum, so what we will need to do is fold, I believe, or we can say elements and sum. Yeah, I think that's that would be the perfect solution. Elements of the map, and we will have sum. Yes, because operators should be imported with parentheses. No type of constructor memory. Wait, where do I use memory? Okay. Let's just say that we have type synonym memory is a map from int to int. We have compile errors. So what's wrong with insert? Expected statement to right. And now I cannot use point free. Now I actually need to apply to memory. .36. So you say I cannot do this? I don't understand you. Couldn't match expected type A4 to int with actual type integer. Read int is applied to too many arguments. read int will return. Oh, right. So I need to use fmap here. Or so inflix-l have lower precedent, which is something that works here. We'll apply mask on read s.
Films and songs that still feel new.
36. Still not working. Okay. Expected type. List of ints. Actual type. A list of integer strings in the second argument of map. Wait. Read int returns read s, right? And read s is a function, right? Oh, I see. Okay, so what? Yes, we'll need first to convert and then to apply mask. Why does it work? Too long to explain, but yeah, because read s is a function, so when we use fmap on read s, it will use fmap for defined for function. But read p is actual new type, and I believe. Wait, is read s? Yes. Wait, read s. Yeah, read s is just type synonym. But read p, which will be read p. Okay, so just believe me, read p is actual type and it has defined fmap as something that actually works. And we cannot use operator fmap because operator of map has lower precedence than just $sign. So it will first try to apply fmap to this function and then to the rest. And we need opposite. We need application going from the right side. 37. Wait. Yeah, because we need lift here. Wait. Couldn't match expected type int with actual. Oh, I see. So that's also the problem, so we solved it. But what's interesting is that result of this is a function, a parser of a function. All right, because mask right now can't be applied to. I actually don't remember why do I need to apply mask at all. Don't know, don't remember. Yeah, great example. Wait. Main example, it's usually complete ls. Did I say? I didn't save the example. Yeah, that's exactly like in an example. Wait, mask is for every operation. I thought. Wait. Oh, I see. Mask is one of the statements. Okay, that's more interesting. So now we say we don't have just one mask. Let me read more. Seaport's computer system uses a strange bitmask system in its initialization program. Also, you don't have the correct I see. Initialization program can either update the bitmask or write a value to the memory. So what we'll have here, so our statement will be different, because we will say that our statement can be either update bitmask, update mask, update mask, or update mask and mask, or it can be assignation, assignment, right? Assignment. Yes, and mask has its own, so assignment or assignment. Cool. And what we previously called statement is actually assignment. Let's say assignment, and let's update mask. Okay, just assignment, and this works because assignment here, no, we will have two constructors. Okay, let's say assignment. Let's say assignment statement. So yes. And if we define it like that, we can we can define read for statement, which will be reading other a statement or a mask. How would it work, you would ask, and I will say, because we have in parser combinators we have an operator plus, which combines, which has an options. Try to read one parser, and if you fail, try to read another, or rather it will combine results, like it will try to read first and it will try to read second. It will output all possible parsing results, and since only one of them is possible by our standards, we will have only one result. Okay, so we've got the same stop. If not, I would have made yours mine. Zone 2, I'd go for you so fine. I would have gone to the end of the line. Zone 2, I've been in my mind. Zone 2, I'd go there all the time. Come 2, we've got to get to mine. To see the plan. Okay, so that's interesting, but what we'll do here is update mask statement fmap on read precedent, and we'll use the same assignment statement on read precedent. It's pretty hot though, I don't know. This is all I know. how does it work? So yes, so read precedent is will return A, type A, and compiler will learn that since we are using assignment statement constructor, so the following read precedent should return assignment, and here read precedent should return mask because we apply update mask statement. So I consider this to be rather beautiful. So statement is not a constructor, sure, but I don't use it as a constructor. Okay, here, yes, here it's not statement, it's actually assignment. And here it's also okay, let's leave execute statement, but we will determine which statement. If it's assignment, okay, we will need I see. What to do? Yeah, let's just use assignment statement. Assignment. It's too tedious, right? Yes, I guess we can improve this by saying assignment, right? So, and we will say address of assignment, and here will be a value of assignment. This way I think it's reasonable. By the way, bits. What is the precedent of bits? I believe it should be high enough, 7, and precedent of plus is 6. Yeah, so that's cool. Bits will execute first. Yeah, what else we need to do here is what if our... Alright, memory is not changed. Okay, good thing that we created type for memory. So memory in our case will include also its actual mem or data, let's say. Of course, date. Date, and second one is mask. Okay, so now what we'll need, mem here. By saying mem here, we actually not inserting into mem. Or or rather we insert it into memory. But we say it's data, and here we are using data of memory. Yeah, it will be easier here to just say where new data is equals this scary expression, and new memory then will be update date. It will be the function, and we will apply an update date on date memory. Strange construction, but it's supposed to work. Here we are, and assignment, but we have also update mask statement.
Tell me what you're going through.
We'll have mask, so here we'll just say that memory and mask is new mask.
Hanging from a thread, there's no way. And your reaction has changed.
But we don't need mask. Yeah, we don't need to mask here. We only need memory. So yeah. Value. Understandable. Value is not understandable. Yay, because I say value and not value. Illegal deriving item show. Yeah, because we need class name show, not function name show. 28. Couldn't match type read precedent with read pair. 28. Oh, assign. Wait, read precedent. Oh, so we don't actually need a list, which is beautiful. Okay, we just need to learn priorities of operator, map operator, which is 4, and the priority of plus 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 is, wait, why? Import qualified text. Qualified text parser combinators read plus plus plus. Wait, so you don't know plus plus plus? Here, plus plus plus. Ah, because it's on read precedent. Wow. Okay, plus 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 plus. And what would be the? Seems like default. I don't see priority of this operator. Plus 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 plus. Let's just try and see. Maybe it will work. So if the priority of plus 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 is the last one, we will have this expression and this expression evaluated first and then only operator. Couldn't much expected read precedent with actual type as yeah, so it's not working like that, but not big deal. Couldn't match type memory with map. Yeah, that fair. Somewhere I assume that map is and which is not, because we just need to get date here, because we need data actually, not the mask. Memory reduction for Dell init memory. Yeah, right, init memory as well. So we will have memory with what we. So initial mask is 0000, I guess. Oh, right. So we have mask as well. So it will be mask on input 0. Replace bits as well 0. Can we get confirmation that the default mask is 0? Initial, then docking you need the sum. Okay, I don't know, so let's assume it's 0. Yay! Example. Yay! Yeah, main. I haven't copied the task input yet. Yeah, task input. Wait. Uh, 600 commands. Task in. Let's try. And not the right answer. Your answer is too low. If you are stuck, make sure you're using full input date. There are also some general tips or hints on the subreddit. Please wait 1 minute before you guessed. That's strange. First, am I using the entire input? Yes. Right? It starts with this mask, yes, and it ends with yes. It's the entire input. So something I did not understand is. So it works on an example, right? But it doesn't here. Interesting. And there is no statements before the first mask, so it doesn't matter what the initial mask is. Okay, what's not working here is so what not working here is update. Probably the mask update is not working properly. What happened? mask update. Alright. I forgot to change the parsing. Right, so now lines, so we can automatically to read each of lines, and we will receive statements. Okay, so we don't need this, and we just apply statements, right? How types hasn't. Alright. Interesting. Couldn't expect. Yes, right, because there shouldn't be mask here. Yes. Mask on input. Yes. Because we don't need to take mask now. And here as well. So we just need memory, date. Yes, that's all. That's actually all. All right, mask on input. Where do we get mask on input now? Right. It will be part of memory, right? So we will say memory data and mask on input and replaced bits. Yeah, I see how it's too long. But that's okay. That's totally okay. So we just here have date, mask on input. Not in scope mem. Why do I need mem? Mem. Okay. Okay, let's put it in separate assignment. Memory mask on input replaced bits mask. Yeah, that's mask here. Hope I can skip parentheses. Memory data mask should be fine. 20. Wait. So we will get memory, we will get data. Data is should be fine. Statements. Yes. Here. Actually, we don't have mask at all. So here we have just exec statement. Execute statement. Main example. It works. Main in task input, it works. Yeah. For some reason, the C ports. Oh, let's have a break for 5 minutes.
Body try and heal me. I know what I want, so come over and hold me. I won't ask for anything more. I'm hurting. You spin out when I'm vulnerable. It helps me fix some love for a little while. I know what I want, so take advantage of me. I don't mind if you take advantage of me. Oh, so take advantage of me. Close your book, no lines. Can't read you if I try. And if that's the way you want it, that's fine. I'll just close my eyes and try to ignore you. I'll free ride for you to hold me. I won't ask for anything more. I'm hurting. You spin out when I'm vulnerable. It helps me fix some love for a little while. I know what I want, so take advantage of hold me. I won't ask for anything more. I'm hurting. You spin out when I'm vulnerable. It helps me fix some love for a little while. I know what I want, so take advantage of me. I don't mind if you take advantage of me. Oh, so take advantage of me. Sorry if I lose my mind. Sometimes, sorry if I lose control when you're not around. Sorry if I make you sad. No, I don't want that. Sorry if it's taking too much from you.
I do not understand the things I've been given in life aren't there, and everything seems against me all the time. I don't know how to stand up, but I've got faith in myself and all of the things I do. I don't need no one else to tell me what I can do. If you don't realize all of the things your life can do, you will be left behind, swept up by the storm of those you hold. I'm just out here chilling with my fam peeps. You don't understand me. If you listen to my songs just a little bit deeper, you might release my dreams, or you might release my inner demons. And that's just a little scary, cause I don't know them, but they all know me. And that's just a little weird, so I keep that to myself. I don't have any real hype right now.
Okay, so start problem. For some reason the Seaport's computer system still can't communicate with your Ferris docking program. It must be using version 2 of the decoder chip. A version 2 decoder chip doesn't modify the values being written at all. Interesting? Instead, it acts as a memory address decoder.
In the main video of Part 9, it was explained that memory regions, such as ROM and RAM, were mirrored across the address space. This addendum will go into more detail on why mirroring exists. While useful in the context of Super Nintendo CPU address space mapping, mirroring is common in other architectures as well. To reiterate from the last video, when a byte is mirrored, it can be accessed from more than one location in the address space. The alternative to a location being a mirror, it could also be open bus, which is when it isn't connected to anything. Let's see what causes both of these to happen. To make this a bit simpler starting off,
Yeah, I think I understand. Immediately before a value is written to memory, each bit in the bit mask modifies the corresponding bit of the destination memory address in the following way. Okay, so we are saying here that we don't modify the value, but we modify the address which we will write to. If the bit mask bit is 0, the corresponding memory address bit is unchanged. If the bit mask is 1, the corresponding memory address bit is overwritten with 1. If the bit mask bit is X, the corresponding memory address bit is floating. Wait, a floating bit is not connected to anything and instead fluctuates unpredictably. In practice, this means the floating bits will take on all possible values. Okay, potentially causing many memory addresses to be written all at once. I see. So that's how mirroring works. You will write in multiple locations. For example, consider the following program. When the program goes to write to memory address 42, it first applies the bit mask. After applying the mask, 4 bits are overwritten. Wait. Address 42, 4 bits are overwritten. Yeah, we have mask. By what values they are overwritten, right? Because we have address, we have mask. So here we have mask x1, 1x. So we say we'll take bit from the address and we'll take bit from the address. But 0 means unchanged, and it is unchanged. So what does 1 mean? 1 means the corresponding memory address bit is overwritten with what? Oh, okay. Okay. 0 is unchanged, 1 is overwritten with 1, X can be anything. This results in address with 3 floating bits. Cool. Yeah, that's interesting. That's really interesting. I'm not sure why Nintendo uses that, but maybe for fast processing. I don't really understand, but nice task. Copy main to star HS. We can also update the stream name, right? Because it's star component right now. For some reason I cannot update the stream name. That's weird. Update the Steam information. Doesn't matter. Or we can do in the YouTube and Twitch directly. Let me do this. Why? It's day 11 for some reason. Doesn't make sense. Something is broken in Restream, at least in docs. And what is the stream name? Achievement level 20. Yeah, that's definitely a previous stream name. Yeah, now I'm not playing Genshin Impact. Wow, that's strange.
Just leave me for somebody else. Enjoy yourself, enjoy yourself. Just leave me for somebody else. Enjoy yourself.
Now I understand, yeah, what you doing. Understandable.
For somebody else. Enjoy yourself, enjoy yourself. She doesn't need nobody else. Enjoy yourself, enjoy yourself. She doesn't need nobody else.
Okay, so how do we need to modify? We still have... Yeah, so mask will now have different information, because it won't have mask on input.
For my enemies, no reason I'll be sitting on the ground now. As I'm dying, I'll be thinking about your face now.
So once again, 0 is unchanged, 1 is replaced by 1, X by anything.
Control yourself, control yourself. I can tell that you don't love nobody but yourself. So please don't put me on a show. I can love you, I can help you feel the way you felt.
I guess mask should be just replaced with a string.
About these letters that you sent into his house tonight. Never get me
Because we cannot represent X in the int. No way.
that you're hitting mine. Enjoy yourself, enjoy yourself.
Yeah, here
Somebody else.
must have a totally different meaning.
Enjoy yourself. Just looking for somebody else. Enjoy yourself, enjoy yourself. She doesn't need nobody else. Enjoy yourself, enjoy yourself. She doesn't need nobody else. Enjoy yourself, enjoy yourself. Somebody else.
So yeah, read mask here is nothing of such sort. He just p munch and a mask constructor.
I wanna tap into my emotion, but I don't think I have it. It's like I sold my soul in, like I got nothing for it. Sometimes I feel okay. Here is a lovely day.
Yeah, so
Yes, I am
data is not changed, data.
Here is a day from hell. I do not wanna go on just praying for better tomorrows. Maybe there's something I can do. What though?
So we will have mirrored addresses.
Going crazy. I don't feel like talking lately. Telling everyone I'm busy. I don't wanna go away, baby. I want you to love, love, love me, but I don't know what's up with me lately. Sorry that I keep you waiting. What do you
Oh,
do
we
when
probably
you
have function
all
2
the
bits
world
or something.
in the world wants all of you, but there's just too much of it. Wouldn't even know what to do with it. Sometimes at 2
We
a.m.
don't really have.
I really need to cry. I wouldn't dare ask why. Just gotta have a
If we don't have
smile.
such function,
I wanna go on just praying for other
so if we have parse int,
something I can
maybe
do
we have
with what
show
though.
int,
Slowly going crazy. I don't feel like talking
show int integral 8. So if we say show int 2, show into 42,
sorry that I keep you waiting.
no instance for num string arising from literal 42. But I don't. Wait. Google show int. Haskell show int. Oh, it's part of numeric. Okay, show int. Oh, right, I see. Int character. Interesting. Yeah, so show float, float 2 digits. No. So again, there is no binary here for some reason. I don't know. They include oct, hex, but not binary. So show int at base will give us base is specified by the first argument into character. Into character. Ah, right. I believe we have show, right? It just no. Char to ditch. It's probably in data char. Also data char, and we should have something like 2 digit to something. Too little, to upper 2, or the 2 digit. Maybe here we have 2 digit in numeric. 2 digit. No. Show digits. From int. don't really know.
I know what's coming now. It's
Then-
only fine, my thoughts. You tell me I get reckless sometimes. I try to keep the
Oh, char. No, char int character is totally different. Yes. Port is different. I forgot. Haskell, we can just find functions that convert int to character. There one. Google. Can I specify prelude? That's interesting. Wait, I write Google help and I... Interesting. Version, variables, numeric question, server, data convert test, package. I guess what I need here is to specify package here, prelude, and we'll set char to show int at base. At base 2 int 2 digit empty string, the int self, which is other, so we will have now a list of digits, and we want to zip it with mask. But what's interesting is that we want to zip it from the last digit, because if result here doesn't have enough digits, you will need to have leading zeros here. Yes, and you necessarily need to have leading zeros because the mask can have X, so you don't want to cut the address just to without leading zeros, because if mask does have X, it should be expanded in the result addresses. So somehow we need to prepend. So what I want to do is reverse here, and then again to reverse. I know that takes linear time to do, but we will have linear nevertheless, so okay, let's say we have probably not doing reversing too much times. We will need 3 reversals. Doesn't work this, I think. Address str, let's say address str, yes, and then we want to have leading zeros. Other str with the leading. Let's just say other str, and we will have here is amount of leading zeros. We have function repeat. Yes, that works. We can also replicate, which works even better. Replicate, is it in data char or somewhere? You see the list. We will replicate length. Alright, 36, right? The mask length is 36. So 36 minus the length of other str is the number of leading zeros. That's all. We should append to concatenate with original address. So now we have to combine mask with address. So in all places where we have 1 or X, we will put them, but where mask has 0, we should leave it unchanged. So what we need to do is to replace masks zeros with the bits of address. So I guess we will have function merge, which will take in the left we will have 0, and in the right we will have anything, and we will join anything. But otherwise we will turn something on the left. So we can zip with merge mask on in no just mask. Actually we can here we can just use deconstruct it in the definition. Zip with merge mask, and we will zip in other str. So now we have result, and we need to convert this result to the list of addresses. So to convert, we'll need to expand each x with 0 and 1. How to do this properly? Yeah, I think that's a good question. I think we should do something like generator, and we will need to yes, that's interesting problem. Yeah, I've got the similar problem on the interview, and I solved it in Go. One solution is to make a recursive function that just replaces stuff, but one of the interesting solutions, a simpler solution, was to iterate from 0 to the power to n minus 1, where n is a number of x's, and you can swap x's with the digits of the iteration variable. This solution isn't that great in the sense that you will need to convert the digit to the string representation, which we already doing, right? So it's not much an overhead here. No, it's an overhead because for each address we will need to 2 to power n times to convert the ints to the digits. So I believe that's not ideal. Yeah, I'll need to think on this. What's the best approach here? Okay, I don't really know. So what if we just start, we will create recursive function and replacing the bits in the list. Does replacing bits in the list harms performance? I don't think so. So just by the virtue of Haskell having list as default, we can do this. But we also want this to be lazy. We don't want to have all addresses in the space, in the place. Yeah, we don't want all addresses to materialize in the same time, because it will take a lot of memory. So what we want is a stream of addresses to update. And Haskell does have has laziness, so we just need to understand whether it will work in this context. I believe the laziness will work here. So what we will do is mirror others. We will have other in the form of string. It will return the bunch of ints. Or strings, doesn't really matter. Let's say string. And what we'll have here is, if that's X, you'll do some magic. If it's not X, mirror other not X, we will return some character, and we will return this character, right? We will return, yeah, so it's not, it's X access, and here we have also access. So if we actually reached the end, we will need to return only one option, which is empty list. If we have just X, then we will need to append this X to every list in access. So it would be map X access. Yes, but if we have X, we will need to have two of them. We will need to map 0 access plus map 1 on access. And plus has probably lower priority than functional application. So it should work, but by itself, I believe. So here what we can do is to just say exit statement. No. So we will have addresses that's masked other. So update dictionary in this case will be since I learned we have in data map strict we have function I believe this one or it was in array. Do we have? Oh, we also have it in the map. Slash slash. It will. Okay, I see. Yeah, I think it works to use slash slash. But maybe we can do better. Maybe there is some like update. Or we can just do foldel insert, which is just as nice, I believe. So we will have foldel. And we will insert. Oh, it's probably. Let's use folder. Just because you don't need to flip the arguments. So we can use folder on the list. No, that's folder on the map. I think union. No. So all functions here are working with two maps. So what I think we'll do here is to just use the command folder and we will insert what we need. Yep. We will have a list of case and we will insert value there. Actually, the element would be on the right or on the left. So because insert, actually let's experiment with having infix for insert, and we will have, for example, for. What are you saying? You don't know backtick parser or on the okay type, and we have k map to map. So that's folder here. So let's use folder then. So update dictionary will be update dictionary here would mean what would it mean? It will be folder folder and in folder we will have insert, but special insert, because we want insert some value which we 100% know its value assignment, yes, and we will use data as in accumulator and the list of mirror addresses and masked other, but we need input ints, so we'll need to convert string to int, and we are doing this by the function readInt. Map, and function is readInt, and we will need to specify. We can specify const true because we know for sure its elements. Do we use int somewhere else? We use it only here. Wow. Okay. We used it in the previous task, I remember. So read int takes base. If I not remember, base character to bool, character to int. Base is of course 2. Character to int is easy. Is character to int. It's easy, right? It's just read. No, we need to digit to character, right? How we did before? Oh, we used enum because we used bool. Yeah, so here we need have dig to int. Yeah, we have it. Dig to int. I guess digit to int. Yes. Digit to int. Yes. Is it all? Yeah, I believe this is everything we need. I believe we can just insert it instead of update data. Yeah, sounds good. It's even works. Yeah, we'll need because we need to mirror add, parse mirror add. And what's wrong with that? Don't fade away. 69. Nice. All right, because you need parentheses here. Completely forgot about them. XXX yeah, empty. Oh, and also you need to have S here. Okay. Not as com other S there because you need to have 2 Ds in the other, right? Wait, do you need parentheses here? Right, because error was not about parentheses. No, it actually was nice. I saw. Show mask. But why would you need show mask? Oh, because my mask doesn't have show. Easy to fix. Wow, errors. Okay, so what's wrong with this? Couldn't match type character with character with string. In the second name of map, namely XS. Are you talking about 48? So here. What can't you understand? Oh, right, because we need characters, right? Okay, 70. 52. In the second argument of map, namely XS, couldn't match expected type character with actual type character. So what we expect is list, right? So XS is a string. Alright, I completely forgot that I need to apply the function recursively, right? So we will have where addresses, mirror addresses XS, and actually we will use others here. Yeah, same problem here. Wait. All right, I need. Wait, what is date? Why do you use date here? I don't know. So I don't use date anywhere here. Does that sound? Ah, here. Yeah, it's here. 59. No, now it's applied to 1. 58. Alright, because we cannot just use read int. Let's say we know for sure, meaning that we can just say head and first. Oh, nice. Mask. Yeah, mask now is just a lot of zeros, right? Replicate 36 0. 68. Pattern matching is overlapping. I don't see how. Oh, right. We yeah, makes sense. I wanted to make it so the simplest case would be handled faster, but we need actually to specify one case, or we could have specify not x but one string for 0, one string for ones, which is even worse. So example, even we are getting infinite recursion. How so? So our mask is 0. Mirror addresses. Let's check this function. What if I say 0? Wow, right, because access should be big. Okay, so this function works good. So what's bad here then? Right, because we are using example, which should be super simple. Because wow, example mask is full of access. Wow. Okay. Then I guess we will need to use finally an array and not map. It should be pretty straightforward. And data array error, and we will get all errors. Emp empty, yeah, sure. So now it won't be replicate. No, mask will be the same. What will be different is not empty, but we'll have array. What function for building arrays we have? Range array. Yeah, I believe we have list array, and that's the perfect function here. We also have function array, but it will take pair of, which doesn't make sense to me. So what we'll have is we will have what happened? Array, list array, and we'll have from 0 to since we have 36 bits, right? 36 bits, then it means 2 to the power of 36 minus 1. And everything will be zeros for the beginning. Let's actually use data, and we also use mask. Cool. Next error, list array. Yes, because MLMs in 23. Yeah, so we have array errors. Right. Browse data array. We have LMs. Yes, we have LMs. So array LMs will be the case here. Yeah, and default are 0, so it works perfectly. To the next error. Not in scope map. Yeah, sure. Because here data is not map, but it will be array. Indexes are int, values are int, and we have insert. And insert will be, instead of insert, we will still have insert, right? Array have insert, right? Insert, update. How do you? Oh, right. There is a socks bounds this, yeah, to slashes function. It will update. Okay, so that's actually perfect, right? We have array, list, and it will update the array, and the array is lazy and it will update lazy, so we will have actually array 2 slashes. So we don't need fold error. What we can do is say, okay, we have your data and we will just update it with arrays that you provided. As simple indices. Do we have indices here? So what we're doing here is yeah, we can do. So what we can do is to say also please pair it. Pairing here is not as simple, but it's simple enough. What we will say here is please, for any address, create the pair address and what value as assignment. Yeah. Value assignment, we don't need parentheses here. Yes, and then not in scope. That's strange. Data array does have so it's not backslash, it's just 2 slashes. Okay, makes sense. 60. What don't you like? Couldn't much expect it in that. Wait, no. In the second argument of address. Wait. So we have map. Right, we need a map. Which is easy to do. Don't even think about it. I wish there was a function to like add, like to add value as a second, as a second element in the tuple, but there is not one. There is function to add it as a. Okay, so what we can do is we have a function, this function. What? But it's not infix, right? Yeah, so we cannot say to put like element on the right side, and but if it's not infix, maybe it's the name of function. So maybe we can use backticks to make it infix. Yeah, parse error on input. No, wait, because infix operation should be in the parse error on input. Let's leave it as that. Main example. Out of memory. What? Out of memory? Are you kidding me? Out of memory. Okay, so how many is 2 to the power of 36? It's 2 to the power of 10 3 times, so it's 10 to the power of 3, which is wait 2 to the power of 10 is the same as 10 to the power of 3, so we have 10 to the power of 9, and it will be kilo mega. What? It will be 1 gigabyte? What? And that's just an example? Are they kidding us? Wow. Wow. Okay, so actually here we don't really have as much access. Okay, so we have another example for this program. Thank you. This example. Okay, so erase doesn't need to be here, and we had a correct decision to use maps instead of actual memory. Wow. Just wow. Wait, 69. Others. I need to do, yeah, this one. Wow. Okay, it's compiles, but we need another example. Wow. Our chilling soundtrack list is ended. Holiday Spirit. I don't really want. PogChamp. Let's use flow music, flow playlist. Wait, flow, kick your feet up to smooth rap
Still curious.
sounds. No, that's not kind of flow I want.
Inside my pants where the fury is. Guilty in the prison what the jury did. Niggas still mad, it's so passion. That's why I go ape.
Okay, synthwave, synth. Example 2, no parse. Wow. Yeah, mass. That was my mistake. 208. Yes, it's 208. So let's run it on task input. Yeah, nice. Cool. So 14 day 14. 5-minute break.